Hey, welcome back. Today we are once again going to be working on my 1966 Chevrolet Corvair. Now, my Corvair is a sedan. It's very much a street car, but it does actually see a fair amount of time on the track over the last few years. It's pretty fun out there, but one of the less fun things about a Corvair on the racetrack is the carburetors cutting out during cornering. And this is something that's kind of inherent in the design of the Corvair Rochester carburetor, and we'll get into some of that here in a little bit so you can see why. And I'll run a little clip of it happening, but it's kind of hard to see and feel just from watching video kind of how pronounced it really is. But the reality is that any stock Corvair Rochester carburetor on heavy cornering is going to cut out, starve for fuel, and you really just lose the ability to kind of generate any power or accelerative force. And to help you get the sense of what that feels like, I'm going to reenact that for you briefly. So you're feeling really good, you're coming into the corner, and you lean in, and then just when you need to put the power down at the apex, it just kind of sits there for a minute or two, and then as it starts to straighten out again, you can get nearly all of those potentially up to 100 horsepower, propelling you at seemingly improbable velocities down the straightaway. So today, we're going to fix that. We'll get into a little bit why it happens, what you can do about it, and we're going to fix the secondary carburetors. Stay tuned. So let's talk about how these carbs cut out during cornering and why. So when the jet is located over here, so this is the way the carburetor would sit in the car normally if the front of the car is this way. This is a left side carburetor. So when you're cornering, if you're cornering, turning left and all the fuel is sloshing this way in the bowl, you can see how the jet would become uncovered, and so you're not going to get any fuel through it. Likewise, if you're going to go in the other direction, this side of the engine is going to get fuel, but the other side is not when the fuel sloshes away from it. So what you do is you move where the jets go. And instead of the jet being over here, we're going to move it so that it goes down. And here, the jet's going to actually go in this direction. We're going to drill holes so that the fuel can still flow like it needs to into the venturi and still distribute the same way, but essentially instead of being delivered from here, from the bowl, it's going to be delivered from this side. And we'll do it on opposite sides on the two carburetors because the way they sit in the car is different. That way the back bowl will always have fuel under acceleration. So when it's sloshing this direction, it's still going to get fuel. If it sloshes this direction under braking, it might starve, but we don't care that much about fuel starvation under braking, right? We care about it under acceleration. This is the Corvair Technical Guide, or the Tech Guide as it's often referred to, put together from a variety of articles published in the communique over the years. I have no idea which version or when this one was published. Wouldn't surprise me if this one was from like the 80s sometime. I believe that you can still get these. I think some guys are still compiling these, maybe even have updated versions of them that you can get over the internet. This is an old one, but not a lot has changed on these cars in a long time. Thanks to R.T. Coffin, I assume that's you, Bob Coffin, writing this article for Colonial Corvair Club many years ago, describing how to actually do the modifications for racing or high-performance driving to help prevent the issues that we're going to try and solve today. Sometimes I like to use tools to make me feel better about the fact that I'm really just eyeballing everything. So in this case, here I am measuring the jet, kind of, but really just basically eyeballing it to make sure it ends up in the bottom of the bowl. Easily the most nerve-wracking part of this process is drilling through the carburetor. But it's not too difficult. You can see here we're going to go straight through the side and then straight down into the body of the carburetor, and it's important that that hole that you're drilling reach all the way to that passage right there in the middle. And I'll test that here, not only cleaning it a bit with the brake cleaner, but also making sure that brake cleaner flows through into that passage. Okay, carburetor on the other side. We don't have that handy little boss to help us locate the right spot for the hole. So I've measured up and kind of lightly scribed a line. And I probably go with this upper line here as my height. And then I've got to get my location to make sure I can punch all the way through into the main cavity here. So I'm going to use a calibrated eyeball to pick the right spot here. There's probably some really good way to measure this that the old school guys know that I don't. But 15 years ago when I did the last carburetor, I'm pretty sure I used this eyeball method. So don't fail me now. Now we've got to tap that inner hole in order to fit the carb jet. But we want the outer hole that we've drilled in the outer body of the carburetor to be fairly small so that it can take a small pipe thread plug later on. I always find that I have to grind down the shank on the tap in order to get the 1/4 inch tap to fit through the hole that's been drilled for the 1/16 pipe thread tap plug. You know what I mean. And now it's time for lessons that I have learned many times over again and yet continue to have to learn. So that awesome tech guide article from many years ago says that you tap the holes for the jets at 1/4 by 20 is the thread that you tap for the jets. So I did. I tapped it at 1/4 by 20. However, that's not right. That's not the actual thread pitch of Corvair jets, which are similar to a lot of other GM and other jets. They're 1/4 inch, but they're 1/4 by 27, whatever the fine pitch is, and then 1/4 by 27, the fine pitch version of 1/4. So yeah, I just basically ruined this carburetor base by tapping it with the wrong thread pitch. I don't think there's any way realistically to get like all the way down in there and you know, fix that. I'm not gonna get a helicoil or anything inside there, not practically speaking. So thankfully I have a shed full of random Corvair parts, including some crusty old carburetors that I can once I stop dropping parts off of it, that I can make a new base out of and start over again. So let that be a lesson to you, as it has so often been a lesson to me. Double check everything before you drill it. Another thing we have to do is plug the old jet holes, and I usually found it easiest to just solder a couple of crappy old jets closed and then use those as plugs in the old jet holes. Okay. Some carburetors are going to have a power enrichment circuit, denoted here by this little passageway here, and also this little vent on this side. You'll see that actually the other carburetor that I had to pull out does not have that power enrichment. So in fact, I don't really have to do anything special with this one. But when you're doing this jet mod and moving things over, it's not a bad idea while you're here to block off and disable the power enrichment circuit. So I'm just going to take a bit of this 1/4 inch bolt that I've cut off. I'm going to put some epoxy on it and drop it in here to seal that off.
Now that we've got the holes drilled, we've got the jets in, we've got our enrichment circuits plugged, now it's time to thread, tap, and then plug the holes that we've made in the outside body of the carburetor. Always a good idea anytime you're tapping to throw a little oil on there. And what I'm going to try to do this first time here is do a 1/16 NPT plug. So I have a 1/16 NPT tap. It's fine thread. So I think it's 1/16 by 27. Personally, I think one of the tricks with this particular application is not to really bottom out the NPT tap, because you don't want the threads, you know, the NPT taps expand as you go down, right? And ideally you would like this plug to get tight before it goes all the way down in there. It'd be nice if it didn't interfere with the float movement or anything inside the bowl. Although being down that low, it should be fine anyway. So, as we say, I'm gonna leave that a little shy of the bottom. Always a bit of a tricky situation. You want it to be tight, you want it to not interfere with any movement of the linkage, and ideally not interfere with the bowl movement either. Maybe you can see in there, I'm just about flush, maybe not quite even flush with the inside surface of the bowl, and it's getting pretty snug. So I'm going to go a little bit deeper with the tap. Oh, borderline. Didn't cut much more, but I cut more than I wanted to. Cut a little more than I wanted to. So it's getting pretty close to being flush with the outside edge before it gets tight, but I think we're okay there. It does protrude into the bowl a hair, but I think we can live with it. Okay, the next thing we're going to do is test the floats to make sure the floats don't have any leaks. Because if the float leaks, then it doesn't float. It sinks, and then it can't shut the fuel off appropriately, which will cause flooding. So we're going to get some liquid of some kind here. And we're going to put the floats in the liquid. Hey, they float. Also, I'm going to kind of hold them down and see if any bubbles show up. Tap them a little bit, look for any bubbles or evidence that water is leaking into the floats. Not seeing any. These look good. Now, furthering my butchery of these delightful 60-year-old jewels of pot metal, I'm also going to cut the air horns out of the top. And you can see I'm just doing this with a hacksaw blade that I took off and I'm using by hand. I mean, it's got to be an air restriction, right? So I'm going to slice these out. It's really not very difficult, and clean up the edges a bit with the blade, and then smooth it out a bit with the die grinder. So about those bowl vents, when you extend them, the challenge is getting them to still fit underneath the stock air cleaner. So as you can see, there's a limited amount of height that you have there. And at that lower level that I have these at, it does clear okay. I apparently don't have this thing situated on here properly, but it will actually sit down flat on there. There's about 1.5 inches of vertical clearance available inside the air cleaner. So you can't just have the bowl vents stick straight up if you want them to be about 2 inches long. Now my first vents here, were not quite as long, and I really want to make them as long as I possibly can because I was still having overflow issues and flooding issues with these vents. Now, pretty tough to get the vents that I epoxied in previously. It's going to be pretty tough to get those out. So instead, came up with the hopefully clever idea of using some just slightly larger brake tubing. This is the copper nickel alloy brake tubing, which actually will slide over the top of the existing tubes and provide a pretty nice fit. I might throw a little epoxy in there as well just to make sure that they stay really tight. However, you got to bend the tops somehow in order to fit underneath the air cleaner, right? What some guys will do is just bend them right here at kind of an angle like this. That probably would work. What I kind of wanted to try in this case was curving them a bit, kind of putting a curved bend into them. To do that, however, I had already cut these pieces, and once they're cut, they are too short to fit in my little bending tool. And if I try to put them in the bender, all it's going to do is crush the tubes. So I think instead what I'm going to do is bend them, then cut them, then install them on the carburetors. And I'm going to go ahead and do the primaries and the secondaries with these longer tubes right now. Okay, a quick reminder of how these carbs work. You've got a needle valve that goes down into a seat. This is where the fuel comes in to the bowl. Call that the needle and seat. Then you've got the float assembly that opens and closes that needle and seat. So when the carb's installed in the car, drops down, fuel flows in, rises up, fuel stops flowing. The goal here is to allow more fuel in the bowl. Now that we have these bowl vents, we want to have more fuel in the bowl so that it's less likely to slosh away from the jet and starve. So stock, these would have, the stock float level for these carbs would probably be, this one's a little aggressive, probably got bent from somewhere else. But even stock, like the cutoff would be somewhere around, closer to level for the floats, being kind of level with the top of the carburetor. In this case, I'm going to take some advice from Michael Levesque, a well-known Corvair racer and builder, and I'm going to actually set them up to have a bit of an incline as they are relative to the seat. He recommends like 0.08 to 0.1 inches of incline, which again basically means it'll allow quite a bit more fuel in the bowl before it cuts off that flow. So we're going to fiddle until we get these things pretty much straight and, aligned with each other. It's pretty easy to bend these tangs over time. So we'll try to make sure that's straight, then get the little tang down here bent to just the right spot so that it closes the needle valve when it's at the right place. Hey, it's Armin from the future. You can tell because of how much smarter and better looking I am than the old Armin. And I kind of got something wrong there. I got the incline backwards. It's not supposed to be inclined up toward the needle and seat. it's supposed to be inclined away from the needle and seat. But it doesn't matter because I ended up going with parallel to the top of the carburetor for the float level, as you'll see now. Okay, and I think we're there. So now you can see that got good parallelism. Plenty of clearance to the gasket. Should shut off the flow of fuel well, but also should allow quite a bit more fuel in the bowl. Okay, there's also a specification for how much the float should drop. So when it's held this way, how much should it essentially open that valve? This is not really that important. It's just intended to kind of keep the float from hitting the bottom of the carburetor. Obviously, in normal operation, you're not going to be fully dropped because there's going to be fuel in there pushing it up. But I think the spec is like 1.5 inches. So right now I have more like 2 inches. It's controlled by another little tang that's on the back here. If you can see that, it's right there. So we'll just bend that slightly to give it a little bit less drop. Time to put carburetors back in. A few notes about this process. First of all, I added the vent tubes to the primaries as well. These are the secondaries that we've been working on, but I went ahead and extended the existing vent tubes on the primaries. Then this linkage here on this 4-carb 140 motor is from Roger Parent, and the stuff is absolutely brilliant. I wouldn't dream of saying a bad thing about it. Unlike the factory linkage, you essentially can eliminate all slop in the linkage through the use of all these Heim jointed ends and even like ball bearings on the pivot points. So really, really nice, really high quality stuff. In my opinion, just a must have for any Corvair, regardless of how many carburetors it has. But I will say, it's a little fiddly to set up and takes a little bit of time. I've done this, I don't know how many times now on this motor because I've had these carbs on and off so many times. My preferred method, if I'm just doing something quick, is to actually just disconnect here so that this whole lever, I just loosen this bolt so this whole lever is free. And I'll do the same thing on this side, on the other primary. And that way I can remove kind of the main crossbar without disturbing too much of the adjusted linkage. Then, when setting it back up, what I'll do is make sure this carburetor is completely closed, which is all the way up in this case. Give it a nice tug. Make sure that the throttle pedal, this is the rod that goes back to the throttle pedal and the spring there, that's hooked up, so this one's fully closed. I'll get this bolt snug over here. And then on this side, I'll force this all the way down to make sure this carburetor is also closed. Slide this one on, snug this one down, and that's usually about all I need to do to make sure that I have what I need. Then I'll usually do a quick check, see if we can get enough light down there to be able to see it. Quick check of the throttle plate. Let's see here. There, you can kind of see it down there. See it move. Make sure that it's fully closing, clear down there at the bottom, and then fully opening. And I'll do the same thing on the other side, making sure it's fully closed and gets fully open. I think we're pretty good. on that score. Then I'll proceed to getting the secondaries put on. Okay, so then when setting up the linkage on the secondary carburetor, the trick is to make sure that it also opens all the way, and ideally then that the two of them on each side will start at the right time. Now, I've done, there's obviously some adjustment you can do with this rod to help with that, which I've done in the past. So I'm leaving that one alone, and instead just adjusting the length of this rod to make sure that it's approximately correct in this new location. So here, what I'll do is, again, just making sure that it stays closed when it's not being opened. Then you can see down there on that bell crank that it'll pop it open, opening the throttle valve way down in the throat of that secondary carburetor. And then when I'm at full throttle on the lever, I'm at full throttle on the primary, and I'm at full throttle on the secondary, all kind of adjusted by the length of that rod. So basically test fitting this a few times till you get that length about right by spinning the pivot on the end. Now I'll do the same thing on this side, and then from a carburation standpoint we should be good to go. Just getting the fuel lines buttoned up and plugging one vacuum line, because that used to be a primary base instead of a secondary base, so that vacuum port needs to be plugged. But we're just about there. Another of the many, many advantages to having an electric fuel pump on your Corvair is that you can prime empty carburetors and then check them to make sure you don't have massive venting issues, or that the needle and seat, like that, for example. Yeah, that's not right. Yeah, I just filled up that side of the engine with fuel, so yeah, let's not do anything too quickly over here. Okay, let's try that again. I adjusted the float level slightly on that carburetor. I don't see fuel gushing out yet. Let's give it a minute. So far, pretty dry. The tone changes when it actually gets full and the fuel flow starts getting shut off. So I think that's actually a good sign. Maybe they're getting full and still not boiling fuel over. Let's check and see if we have an accelerator pump shot. It's weak, but there's something in there. I don't know if that'll show up on camera or not, but there's a little bit of fuel. How about this one? Nothing in that primary. Nothing here either. I got a little in secondary though. Yep, secondary's got a nice strong shot. Yep, primary's got a little bit. So just this primary is dry right now. Now, as much as I'm getting tired of doing this over and over again, I think I probably need to do it one more time. I think we're going to take that primary off and see why we're not getting the pump shot. Could be that needs to be cleaned out again. Okay, another reason to take this primary off. You can kind of see that leak there. It's going to be impossible to see on camera, but like 15 years ago when I modified the primaries to move the jets, I have a pipe plug in the side of the bowl, and that pipe plug is leaking now. So I'm going to pull it off anyway to fix that, and then we'll take the top off and see what needs to be cleaned out. Okay, and that one, new pipe plug put in to hopefully stop the leak. Cleaned everything out, didn't really see any serious gunk, but hopefully clean enough that we'll get fuel to flow properly. That guy's still on there. Everything's snugged up again, I think. Nope, forgot to do fuel lines. Hang on. Okay, fuel lines are good to go. Time for another test. No giant rivers of fuel so far. Tone of the fuel pump changed. I think there's a good chance that there's fuel in the carbs now. Let's look for that accelerator pump shot. Sure I have the lever hooked up. I do. Still nothing from the primary. Nothing leaking out the backside of the carb right now. That's a good sign. Secondary has a great pump shot. Oh, there it is on the primary. There we go. That's good. Let's check these guys. There's wet down in there, which is a good sign. Yep, there's a good squirt. There's a good one. All right. We got some fuel. And seems to mostly be contained into the places that we want it to be. All right, that's it for this video. Thank you so much for watching. Unfortunately, I will not be able to fire it up and do any test driving today to see if the problem is solved. Number one, because it's kind of hard to tell on the street anyway. It's hard to get that much lateral G loading for a long enough time to get them to starve out. And number two, because I have another broken car in the way that I can't drive, so I can't get the Corvair out today. Plus there's this, like, I think it's like the heat index is like 115 degrees today or something. It's nasty. I think I'm done, but thank you. Consider subscribing, share this if you know anyone who needs to learn how to rebuild a Corvair carburetor for performance reasons. Thanks again. See ya.